potential energy. Clear? So, what is meant by gravitational potential energy? Definition we will study in the last. First of all, we will study what is the basic concept behind this gravitational potential energy. Okay, Sima. So consider there are three masses. So this is mass m1, this is mass m2, and this is mass m3. Three masses are present, and all the three they are present at infinite separation. All the three masses they are present at a very large separation, infinite separation. Are you able to understand? Distance between these two is also infinite. Distance between these two also infinite. Distance between these two also is infinite. Infinite means they are present at a very large distance. So force of attraction between them will be how much? Zero. There is no force of attraction. Clear? Now what I do is I want to bring this mass m1 up to somewhere here, this point. Let us consider this point to be point number 1. Okay, ma? So I want to bring this mass from this infinite position to a position of this one, this position. Okay. Then let us consider the amount of work which I have to do, W1. Okay. Now can you say W1 value will be how much? Can you say, anybody? To bring the mass from infinite separation to any position, okay, let the amount of work done is W1. So W1 will be how much? 0. Why? Very good. Sima, if I want to bring this mass from infinity to this position, I need not apply any force. Force apply cheyalsina avasaramu ledu. Why? Why I need not apply any force? For example, to lift this pen upwards, I have to apply some force. No? Why? Because in opposite direction, gravitational force is pulling this pen. So why I am applying force? To oppose the opposing force, that is gravitational force. Okay. Similarly, if I want to move this pen downwards without any acceleration, then also I have to apply force. Because if I release this pen, it moves with an acceleration. So I have to apply equal and opposite force equal to weight of this pen, then I have to move it downwards. So either in moving upwards or downwards, I am opposing gravitational force. Clear? No? But when I am bringing this body up to here there are no opposing forces. No? Nobody is opposing the movement of that mass m1. Dini movement ni evaraina oppose chestu unnara? Nobody is opposing. So therefore, I need not do any work. Just I will say, mass m1, please go up to here, then it will travel up to here. Understood, Nama? No need of applying any force. So I can say, first work done is how much? 0. Work done to move this mass from infinite position to this position is 0. Okay, ma? Now, I will take this second mass, which is again at a very large separation, and I want to bring this mass to a particular distance in the gravitational field of mass m1. So mass m1 is present here. Now I am placing mass m2 here. Are you able to understand, ma? Mass m2. Are you able to understand? Now here the amount of work done is W2. Okay. Now W2, how can I calculate? How can I calculate? Now to bring this mass m2 to this position, shall I need to do some work or not? Work cheyalsina avasaram unda leda? I have to do some work. Why I have to do some work? Because m1 is continuously pulling this m2, no ma? Gravitational force is always attractive. Okay, ma? To oppose this attracting force, I have to apply force in opposite direction, and slowly I have to bring this mass up to here. So definitely I have to do some work because force is applied and displacement is also there. Are you able to understand, ma? Now, how can I calculate work done in second condition? So W is equals to V into M. Already we have studied, no ma? What is V into M? Let this one position 1 and let this one be position 2. Okay. So already we studied, Nama, potential is nothing but work done per unit mass. Therefore, work done will be how much? V into M. Okay. Now what is meant by V here? V means what? Potential at this point. At this point, who is giving the potential? M1 is giving the potential. Are you able to understand? At this point, this M1 will give potential. Okay. And I am doing work against this potential. So W is equals to potential multiplied by the charge which you are moving, or the mass which you are moving. Are you able to understand? So therefore I will write W2 is equals to V12, I will write, multiplied by which is the mass I am moving. The mass which I am moving is M2. Are you able to understand, ma? Now, what is the equation for potential due to a point mass? Potential is equals to minus Gm1 divided by R12. Okay, ma? So this distance I will consider to be R12. Are you able to understand? Potential due to a point mass, V is equals to minus Gm by R only, no ma? This is the equation for potential. No? So therefore V is equals to minus gm divided by r. Which mass here? Which mass is giving potential? m1. And what is the distance? Distance I am calling as r12. Are you able to understand? So this much amount of work I have to do, multiplied by which mass I am moving? I am moving mass m2. So therefore minus g m1 m2 divided by r12. So this much work I have to do to shift this mass from this position to this position. అర్థమవుతుందా ఏం చేస్తున్నాము? క్లియర్ నమా? ఓకే. నౌ వీ హ్యావ్ వన్ మోర్ మాస్, నో? క్లియర్ నమా? సో షిఫ్ట్ దిస్ మాస్ ఆల్సో somewhere to this position. Okay. Now here let the amount of work done is W3, and let us call this position to be third position, and up to here I am bringing the mass. Now anybody, can you say how can I calculate W3? W3 how can I calculate?
M1 plus M2.
Huh?
M1 plus M2.
Work done is nothing but V into M only, no? So let us proceed according to the basic definition. Definition ప్రకారం proceed అవ్వండి, కొండజాతి ఆన్సర్లు వద్దు మనకు. అర్థమవుతుంది కదా? సో W is equals to V into M. V means what? Potential at this point. Are you able to understand? Can you say at point number 3 what is the potential? At point number 3 what is the potential?
V1 plus V2.
At point number 3 there will be two potentials. Okay ma? Mass M1 also will give some potential, no? Mass M2 also will give some potential, so there are two potentials. Are you able to understand? So if I draw this line, let this be M2. So this is one line, this is another line. Let us call this distance to be R13, and this distance is R23. Are you able to understand, ma? So therefore I can say that W3 is equals to V13 plus V23 multiplied by, and which is the mass I have moved, ma? I have moved mass M3. This is the method which I have to adopt. Are you able to understand? Now potential due to first mass at point number 3 is how much, can you say? V13 is how much? Minus G M1 divided by R13. That's all. No? Potential formula minus Gm by R only. No? I am calculating potential because of first mass, so it is M1. So minus G M1 divided by what is the distance? R13. So R13. That's all. No? So minus potential due to second mass, minus G, minus already we have written, no? Okay, minus G M2 divided by R23. Distance is R23 only, no? Clear, no? Multiplied by which is the mass we are moving? I am moving mass M3. Okay. So therefore do this calculation. So W3 is equals to how much? So minus G M1 M3 divided by R13 minus G M2 M3 divided by R23. So this is the amount of work which I have done. Okay. Are you able to understand, ma? So therefore what is the total work I have done? Total work done to assemble charges, at a given configuration, at a given or at a particular configuration. This work done is nothing but W1 plus W2 plus W3, no? Okay. W1 is how much? 0. W2 is how much? Minus G M1 M2 divided by R1. W3 minus G M1 M3 divided by R13, and minus G M2 M3 divided by R23. So this is the total amount of work which I have done to assemble the charges at a particular position. This is the amount of work which I have done, no? So this amount of work done is nothing but gravitational potential energy. అర్థమవుతుంది కదా? So what is meant by gravitational potential energy, ma? The amount of work which we have to do to assemble all the charges at one position. That is called as gravitational potential energy. Okay, ma? It means this much amount of negative work I have to do. And definitely work done is negative only, no? Because forces are all attractive. If I have to move mass in this direction, I have to apply force in opposite direction. So every work done is negative. And if I supply same amount of positive energy, then can you say what will happen? So అన్ని ఇక్కడ అసెంబుల్ చేయడానికి ఇంత నెగిటివ్ వర్క్ చేయాలి నేను. If I supply same amount of positive energy to these masses, then what will happen? They will get separated again to infinite distance. That is also called as gravitational potential energy. Second method of defining. Okay, ma? So how can I define gravitational potential energy? The amount of work done to assemble all the charges at a particular configuration is called as gravitational potential energy. Or how you can define the amount of energy which I have to supply to the charges so that they move to infinite separation is also called as gravitational potential energy. అర్థమవుతుంది కదా? Make a note. Clear, ma? Now, see, ma. So, see, ma, how to remember this formula? First of all, see here. So, G M1 M2 by R12. So, M1 M2 will form one pair, no, ma? M1 M2 will form one pair. Okay. Next relation is M1 M3 by R13. It means the first body and third body will form one pair. Next, G M2 M3 by R23. It means second body and third body will form one pair. So therefore, how many equations we have to write, like how many terms we have to write? The number of terms you have to write, which is equal to the number of pairs which are possible in this condition. Okay. For example, let us see. Okay, ma? See, ma. So, for example, this is mass M1, this is mass M2. How many pairs are possible? Only one pair is possible. Clear, no? So, therefore, gravitational potential energy can be written as minus G M1 M2 divided by R12. That's all. This is the formula. Okay, ma? So, this is the equation for gravitational potential energy between two charges, two masses. And case number 2. Okay, ma? Case number 1. So, case number 2 is, consider there are 3 masses. First mass, second mass, third mass. So, mass M1, mass M2, and this is mass M3. Clear? How many pairs are possible? This is one pair. Okay, ma? R13. This is second pair. R12. And this is third pair. R23. 3 pairs are possible. So, therefore, you have to write 3 equations. That already we have written, no? Clear, no? So, what is the total gravitational potential energy? So, it is given by minus, first you take first pair. This is first pair. Minus G M1 M2 divided by R12. Minus G M2 M3 divided by R23. Minus G M1 M3 divided by R13. These are the 3 pairs. Okay, ma? And case number 3, if there are 4 masses, 1, 2, 3, 4 masses. So, M1, M2, M3 and M4. Then how many pairs are possible, ma? Can you say? 4, no. Think carefully. 6 pairs are possible. 1 pair, second pair, third pair, fourth pair, fifth pair, sixth pair. 6 pairs are possible. Are you able to understand? So, you have to write one gravitational potential energy equation for every pair. 6 pairs are possible, no? So, therefore, you will get 6 terms in this equation. Okay, ma? And number of pairs to calculate, we have a shortcut formula, ma, that I am writing here. Okay. So, number of terms possible is equals to n into n minus 1 divided by 2. That is the formula. Okay. Where n is called what? N is called number of point masses. Number of point masses. Understood, no? N into n minus 1 by 2. For example, you take here, n value is how much here? N value how much? N value only 2, no? 2 masses are there. So, substitute in this formula. N into n minus 1 divided by 2. So, 2 into 2 minus 1 divided by 2. 2 get cancelled, 1. Only one pair is possible. Understood, no? In second case, how many pairs, how many masses are there? 3. So, substitute 3 there. 3 into 3 minus 1 divided by 2. Okay, ma? 2 and 2 get cancelled, 3 pairs. 3 pairs only now we got. Clear? Now, substitute here. Case number 3. Total how many masses? 4 masses. So, 4 into 4 minus 1 divided by 2. So, 2 1s are 2 2s are 2 3s are 6. 6 pairs are possible. So, this is the formula which you can remember. So, like that he can ask for any number of masses, 4, 5, 6, 7, any masses. Just substitute in this relation n into n minus 1 by 2 to get number of pairs. Then formula is the number of, not terms, terms also you can write, number of pairs you write down, that is better. Number of pairs possible. Okay? N into n minus divided by n minus 1 divided by 2. That is the equation. Understood, no? Very, very important concept. Many times questions were asked on gravitational potential energy. Okay? See this question, ma. So, question based on gravitational potential energy. So, 3 particles, each of mass m, they are placed at the corners of an equilateral triangle of side A. Find the work done in increasing the separation to 2A. Clear, no, ma? So, it means initially there is an equilateral triangle, ma. And what is the side of equilateral triangle? A. Okay. So, at the corners, we are placing 3 masses, and the mass of each of them is, it means masses are equal. 3 masses. Mass m, This is also mass m and this one is also mass m. Okay. Now what I want to do is, I want to increase the separation between the masses to 2a. It means I have to convert this equilateral triangle into a bigger triangle. Now whose side will be equal to how much? Whose side will be equal to 2a. Masses are same. Okay. So distance should be 2a, 2a and 2a. Okay. It means this mass I have to take up to here. Okay, ma? This mass I have to take up to here. This mass I have to take up to here. So that the new triangle formed, it will have a length of 2a. 2a, 2a, 2a. Understood now what is happening here? So then in this condition, how much amount of work I have to do? Anybody, can you say? How can I do this calculation, ma? How can I do? What is the method of solving this problem? In which? This distance you need not find out, already it is given. Tell more clearly. So very simple here. In the first condition, okay, first condition means what? When they are present at a separation of A. Okay, when they are present at this separation, first you calculate total gravitational potential energy, and let us call it as GPE1. Okay. Then in the second condition, in this condition we will have a different gravitational potential energy. No? That energy we will call it as GPE2. What is meant by GPE1? Work done to assemble the charges at this position. That is called GPE1. Gravitational potential energy is nothing but work done only to assemble the charges at one position. Okay. And what is meant by GPU2? The work done to assemble at a distance of 2a. So therefore, what is the net work we have to do? Net work done is equals to GPE2 minus GPE1. That's all. So here there is some energy stored in the system. Here there is some energy stored in the system. So this energy minus this energy will give the amount of work done to make this configuration from this configuration. Okay. So first make a note of one point. Okay. Note point is that the work done in assembling the charges, from infinite separation, is stored as gravitational potential energy inside the system. Are you able to understand, ma? Is it clear what is happening? Okay. So whatever work you have done to assemble them at one position, that work should be converted into some another form, no? Because we have law of conservation of energy, no? Energy can neither be created nor destroyed. It has to be converted from one form to another form. So the work which you do, it converts into what? It converts into gravitational potential energy of these charges. Okay. So just GPE2 minus GPE1 will give the amount of work which I have to do. That's all. Okay. Now we know how to calculate gravitational potential energy of a system, no? So GPU2, how can I write? GPE2, how can I write, ma? How many pairs are possible? N into n minus 1 by 2. So 3 into 3 minus 1 by 2, how much, ma? 3 into 2 by 2 is 3. 3 pairs are possible. What are the 3 pairs? So first pair, second pair, third pair. 3 pairs. Masses are equal, no? Distance is also same, no? So directly you can write 3 multiplied by, because for every pair masses are same, distance is also same. So 3 into minus G m into m divided by 2a. This is what I can write. No need of writing 3 terms, no, ma? Just I multiply by 3, because every pair you will get same value. Okay, so 3 into minus G, so if you do this calculation, how much it will be? Minus 3 by 2 G m square divided by a. So this is the amount of energy stored in second system. In the energy store, because same amount of work we have done to assemble them at this position. ఇంత వర్క్ చేసాం కదా మనం, అదే వర్క్ అక్కడ పొటెన్షియల్ ఎనర్జీగా స్టోర్ అయి ఉంటుంది. క్లియర్? దెన్ క్యాలిక్యులేట్ ఎనర్జీ స్టోర్డ్ ఇన్ ఫస్ట్ సిస్టమ్. GPE1 is how much? Minus 3, first you will write 3 multiplied by minus GMM divided by A only, no? A. Okay, so therefore how much it is? Minus 3 GMM divided by A. So therefore, what is the net work done? Net work done to move from first configuration to second configuration is GPE2 minus GPE1. Okay, ma? So therefore, GPE2 minus 3 by 2 GM square by A minus of minus 3 GMM divided by A. Clear, no, ma? So therefore, GM square I will write. GM square. So minus 3 by 2 GM square by A plus 3GM square divided by A. So 3GM square by A I can take common, no? So then it is 1 minus 1 by 2. Then it is 3 by 2 GM square divided by A. So that is the amount of work which I have to do. Okay. So if I do this much amount of work, then this configuration converts into this configuration. That's it. Okay. ఏవిరా
ప్లస్ 3
క్యాన్సిల్ ఎట్లా చేస్తారా? కానీ ఒక దాంట్లో 3/2 దాంట్లో 3నే ఉంది. నేను రాసింది అదే కదా. ఓకేమా? So let us see this problem. So a particle is fired upwards with a velocity v0 from the surface of Earth that he forgot to give. Then find the speed at a distance 2 re from center of Earth. Re is radius of Earth. Calculate maximum height obtained by the particle. So let us see the first one, how we can answer this. See. So consider this is Earth. Radius of Earth is Re. Okay. So initially, and mass of Earth is how much? Mass of Earth is capital M. Radius of Earth is Re. Okay. And here there is one point mass whose mass is not given. So let us consider its mass to be M. So from here it is given a velocity of v0. Are you able to understand? Then find upwards. And when it is at a distance of 2 re from center of Earth, that is by the time radius of Earth is this much, no? 2 re means where? Somewhere by the time it reaches here. So 2 re from center, no? Therefore it will reach up to here. Okay, ma? So therefore from the center, what is this total distance? This total distance should be 2 re. It means from here to here it is re, no? And this is one more re. Are you able to understand, ma? So therefore we can write separately here. One distance is re and height is also how much? Height is also re. That is the data which he gave. Okay. So by the time this particle reaches here, again it will have some velocity v, and that velocity v only we are supposed to calculate. Are you able to understand, ma? Clear? So velocity at the surface of Earth is v0. By the time it will reach to a height of another re, so total from the center distance will be re plus re 2re. Distance always should be taken from where? From the center only. So from the center total distance is 2re. It means radius of Earth is re, height traveled is another re plus re 2re. Understood, no? So here velocity will be v, that velocity I have to calculate. Now can you say which method I can use to do the calculation? Kinematics తో ఎట్లా యూస్ చేస్తావురా?
velocity ఇచ్చారు కదా. Initial 0 velocity ఇచ్చారు.
చేయొచ్చు. Which equation by which method I can do? Anybody? Try to think. Kinematics we cannot use here because distances traveled are very large distances. No? G value will change continuously. V square minus U square is equal to 2SSN equal to UT plus half. All you can use only when G is a constant. G is not a constant. Because what is the height traveled by the mass? Equal to the radius of Earth. ఎంత హైట్కి వెళ్ళింది? రేడియస్ అంత హైట్, అంటే ఇట్ ట్రావెల్ నియర్లీ 6,400 kilometers. So G value is not a constant, it is continuously changing. So equations of kinematics we cannot use. Any other method? It is not revolving, it is moving in a straight line. Already I said, you know, if there is no other way, use law of conservation of energy. ఏ దారి లేనప్పుడు గోదావరి మన దారి అన్నమాట. Okay, what is law of conservation of energy? See here, all the forces are only gravitational forces, no? All forces are which forces? All forces are gravitational forces. And gravitational force is what kind of force? Conservative force. Clear, Nama? And when conservative forces are, are acting, which equation you can use? You can use law of conservation of mechanical energy. What is law of conservation of mechanical energy? K1 plus U1 is equals to K2 plus U2. That's all. Use this relation, you will get the answer. Okay. So K1 plus U1 means when body is present on the ground. K2 plus U2 means when body is present at a height of h. Okay. Now do the calculation. What is the initial kinetic energy when it is thrown? 0 అయితే పైకెట్టబోతుంది అది. Initial kinetic energy is half mv naught square. That's all. No? Initial potential energy? Amma. No. Distance we have to take from the center. Distance between earth and this mass is how much? This is the distance, RE. And what is the formula for gravitational potential energy? Minus g mm by r. Just now we have calculated this only 2 masses, no ma? 2 masses means 1 pair. 1 pair means only one equation you have to write. Okay. So therefore minus g capital M into small m divided by RE. This is the initial gravitational potential energy. That's all. Distance between point mass and earth is RE. Only 2 masses, no? So only one pair is possible. Already we have studied now which equation n into n minus 1 by 2. How many masses? 2 masses. 2 into 1 by 2 is how many? 1 pair is possible. So minus gmm by r. Okay. So this is equals to final kinetic energy. Final velocity I am considering to be v. So final kinetic energy is how much? Half m v square plus minus only. Final potential energy. Now point mass and earth, they are separated by how much distance? 2r distance. So calculate. So minus g capital M into small m divided by 2re. Center. Distance should be from center. Spherical bodies, they always behave like point masses. Already I said, distance should be taken from the center itself. Okay, ma? So from this what I want only v only, no? So calculate v value, that is our answer. Understood, no? That's it. So calculate v value, whatever you will get, that will be your answer. Okay. So the answer which he gave is V naught minus gm by r. That is our answer. Okay, ma?
Sir, GM cancellation of minus GM.
This is the answer. చేత్తో ఇట్లా చేస్తే వస్తుంది. సో క్యాన్సల్ దిస్ ఎం 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 అండ్ ఎం ఏముంది వచ్చేసింది అంతే. ఓకే. సో దేర్ ఫోర్ ఎట్ట క్యాన్సల్ అవుతారా? ఇక్కడ ఆర్ఈ ఉంది, ఇక్కడ 2RE ఉంది. ఎట్ట క్యాన్సల్ అవుతాయి? కామన్ తీస్తేనే మీరు చేయగలుగుతారు దాన్ని. అట్టా చేసారు ఆడనా? అవుతాయా? అంటే నీ మ్యాథ్స్ ప్రకారమా మామూలు మ్యాథ్స్ ప్రకారమా? చెయ్యండి, ఇది రావాలి ఆన్సర్, అది విషయం. ఎట్లన్నా చేసుకోండి. ఇది రాదంటావు అయితే కష్టం రా. ఓకే. సో v naught square by 2 minus gm by re is equals to v square by 2 minus gm by 2re. Okay, ma? So send this value to this side. So v naught square by 2 minus gm by re plus gm by 2re is equals to v square by 2. Okay, ma? So v naught square divided by 2 minus. So what I will take common here, I will take a plus gm by re. If I take common, then it is minus 1 plus 1 by 2. Okay, ma? Is equal to v square by 2. ఇవి కూడా నేను చేయాలంటే చాలా కష్టం రా. ఓకే. సో v naught square by 2 plus gm by re multiplied by minus 1 by 2 is equal to v square by 2. 2 get cancelled. So v square is equals to v naught square minus gm by re. So v is equals to square root of v naught square minus gm divided by re. That's all. That is our equation. చాలా కష్టం. Okay, ma. See, ma, further also we can simplify. Already we have studied that G is equal to gm by r square. No, ma. Do you remember? Acceleration due to gravity formula, gm by capital R square. Okay. Here I have only gm by r, no? So you send one r to this side. So g r square can be written as gm by capital R. So take this value and substitute here. So therefore v is equal to square root of v naught square minus g r square. You can write like this also. Understood, no? So v is equals to v naught square minus g r square power 1 by 2. You can write like this also. Whatever answer is present in the option. Hedi? gm by r square. నేను ఎప్పుడు చెప్పినారా మీరు ఏందో పిచ్చి క్యాలిక్యులేషన్ చెప్తుంటే తప్పన్నా కానీ అది ఓకే ఓకే సో హియర్ జీ ఆర్ ఓన్లీ మా ఆర్ స్క్వేర్ ఇస్ నాట్ దర్ ఓన్లీ ఆర్ okay. So whatever option is present in the final answer, according to that you have to proceed and do the calculation. Okay. Now see ma. So second question is also given. What is the maximum height obtained by the particle? Okay ma. Now can you say what is the difference between first condition and second condition ma? Difference between first condition and second condition is what? In the first condition I want to speed at a height of r. At a height of h is equal to re, I have calculated speed. Second condition, maximum height. Maximum height means? Maximum height means what? Maximum height means after reaching that h max, velocity of the particle will become 0, no? That is the point which you should remember. If I throw a stone upwards, at maximum height, how much will be its velocity? 0. It means the final velocity should be taken 0. Okay? So therefore, let us consider body was thrown from here, and body after reaching to this height, okay, its final velocity has become 0. Initial velocity is v0. This is the condition. Okay. Now again use the same law of conservation of energy and do the calculation. Chain link you can do. Okay. So all forces are again gravitational forces and they are conservative forces, no ma. So therefore I will write k1 plus u1 is equals to k2 plus u2. Law of conservation of mechanical energy. So initial kinetic energy half m v0 square. Initial potential energy minus gmm divided by re. Final kinetic energy 0. Final potential energy minus gmm divided by re plus h. Okay, because h is the value which I have to calculate. Nama, this height I have to calculate, at which its velocity has become 0. Okay, now do this total calculation. Calculate h value. That is my required answer. ఇది బాగానే ఉంది సార్, ఇది చేయడమే మాకు రాదంటారు వీళ్ళు కదరా. చేయండి ఇంకా. ఓకే. Okay, ma? So this is our answer for the question. V0 square Re divided by 2gr minus V0 square. So it means answer is not present in terms of capital G, no? Okay, ma? So we know that G is equal to gm by r square, no ma? So instead of gm, what you can write? Instead of gm, you can write gr square. Okay? So wherever you find gm, there you substitute gr square. Then this is the format of equation which you will get. Okay, ma? So check whether you get this final answer or not. Fine. Answer in present in terms of only small g ma. It means instead of gm, he should have placed gr square. Okay? That's it. See ma, let us see this problem. So, two masses m1 and m2 initially they are at rest position and at infinite distance apart. So they approach each other due to gravitational attraction. Find the speed of approach at the instance when they are a distance r apart. Okay, ma? We will try to do this problem in two methods, ma. So method number 1. Very, very famous questions, ma, these are mostly asked in competitive examinations. Okay, so let us see. So initially the masses m1 and m2, they are at infinite separation. It means distance between them is how much? Distance between them is infinite. Very large separation. Okay. Now they started coming towards each other because of mutual gravitational force of attraction. And when they are a distance r apart, it means one body is here, another mass is here. Now what is the distance between them? Distance between them is v. Then this body will have a mass of v1 and this body will have a mass of v2. That's all. No? Masses are different, you know. So speeds also will be different. So find the instance when they are distance r apart. So when they are at a separation of r, find the speed of approach. Speed of approach means relative velocity with which they are approaching with each other. Okay, ma? So speed of approach, how can I calculate? Speed of approach is equals to relative velocity of first body with respect to second body, v12. This is how I can calculate now. Okay, ma? I can write v1 minus v2. So v1 minus of minus v2. Why I am writing minus v2? Because velocity is there in opposite direction. One velocity is in this direction, another velocity is in another direction. So if I take one velocity to be positive, another velocity should be negative. So this is the relative velocity with which one body is approaching the second body. Then second body also approaches the first body with same speed. Okay, ma? So therefore relative velocity is v1 plus v2. So first of all I have to calculate v1 and v2, then add both of them, then that is my answer. Understood? First of all you have understood, Dhamma, what is meant by relative velocity. So one body approaches another body with how much speed? It means if I take first body to be in rest position, then I can take relative velocity. In relative velocity, always first body goes into rest position. Only second body goes into rest position. Only first body is approaching the second body. Understood, no? So with this velocity, one body is approaching another body. Okay. Now how can I calculate v1 and v2? Okay, ma? Two unknown quantities are there, no? So I have to write two equations. First equation, how can I write? First equation, I can write by using momentum conservation equation. Momentum conservation. Okay. Why I am using momentum conservation, ma? Because on this system, are there any external forces? ఊరికే కాన్సెప్ట్ చదవడం కాదు, అవసరం వచ్చినప్పుడు వాడాలి దాన్ని. అర్థమవుతుంది కదా? లా ఆఫ్ కన్జర్వేషన్ మొమెంటం ఆల్రెడీ వీ హ్యావ్ యూ స్టడీడ్, నో? సో హియర్ ద అప్లికేషన్ స్కిల్ that totally depends on your practice. Understood, no? So if you take this total to be one system, are there any external forces acting on this system? External forces unnaya? Levu. These bodies are approaching only because of mutual force of attraction, gravitational force. So external forces are not there. So if external forces are 0. If external forces acting are 0, then momentum is conserved. Already we have studied, no? Momentum is always a constant. So total initial momentum and total final momentum, they should be equal. Okay. What is the initial momentum? Initial momentum is 0. 0, no? Because when they are at infinite separation, they don't have any velocities. Initial velocity is 0. Initial velocity of second body is also 0. So initial momentum is also 0. Momentum mass into velocity only, no? Final momentum. So mass of first body, m1. What is its velocity? v1. Minus of, why I am writing minus? Because velocity is in opposite direction. So therefore m2 v2. Clear, no? So therefore m1 v1 is equals to m2 v2. This is my first equation. Understood, no? So this first equation I got from where? I got from law of conservation of momentum. Because momentum is a constant. అర్థమవుతుంది కదా? ఫిజిక్స్ అంటే ఒక చాప్టర్ ఫార్ములా చదివేసినా వచ్చేస్తే లెక్కలు అనేది కాదు, మొత్తం కాన్సెప్ట్ అంతా ఐడియా ఉండాలి. దెన్ ఓన్లీ యూ కెన్ డూ ఎనీ కైండ్ ఆఫ్ ప్రాబ్లమ్. అండర్స్టూడ్, నో? సో నెక్స్ట్, సో ఐ వాంట్ వన్ మోర్ ఈక్వేషన్. సెకండ్ ఈక్వేషన్ ఫ్రమ్ వేర్ ఐ కెన్ గెట్, మా? Two unknown quantities are there, no? v1 is one unknown quantity, v2 is another unknown quantity. But I have only one equation. I require another equation. Second equation from where can I get? చెప్పండి, ఆలోచించండి, ఎక్కడి నుంచి వస్తుంది ఇంకొక ఈక్వేషన్? Law of conservation of mechanical energy you can use, no? So k1 u1 is equals to k2 plus u2. This equation you can use. దేశానికి డాక్టర్ కావడం అంత ఈజీ కాదు రోయ్. పేషెంట్ ఉంటాడో పోతాడో అనే సిచ్యువేషన్లో వస్తాడు మీ దగ్గరికి. మీరు పిచ్చిపుల్ ఫేస్లో వేసుకొని చూసే లోపల పోతాడు వాడు పైకి. అర్థమవుతుంది కదా? సిచ్యువేషన్ని అనలైజ్ చేసి ఆ ఒక్క సెకండ్లో వీనికి ఏ ట్రీట్మెంట్ ఇవ్వాలి అంత షార్ప్గా ఉండాలి డాక్టర్ అంటే. సో అంత హార్డ్గా మీరు తయారవుతేనే అప్పుడు భగవంతుడు డిసైడ్ చేస్తాడు వీనికి ఎలిజిబిలిటీ ఉందా లేదా డాక్టర్ చేయడానికని. అర్థమవుతుంది కదా? లేదంటే ఎవడొస్తే వాడికి మీ పిచ్చిపుల్కి ఆపరేషన్ ఇవన్నీ చేసినారు అనుకోండి, పోతాడు వాడు పైకి. హిమాలయ హాస్పిటల్లో ఒక డాక్టర్ ఉండేవాడు. వాడు అప్పుడే ఎంబీబీఎస్ ఎండీనో ఏదో కంప్లీట్ చేసి వచ్చినాడు. వాడు ఏదో ఎస్సీ ఎస్టీ రిజర్వేషన్స్లో ఏమో వచ్చింది వానికి. అంటే ఒక అక్షరం చదువు రాదనే అర్థం దానికి. అక్కడికి మా అమ్మకు ఏదో దగ్గు వస్తూ ఉందని పోయింది. పోతే స్కాన్ అంతా చేసి నీకు టీబీ ఉంది మా అన్నాడు. మాకేం తెలుసు డాక్టర్ పిచ్చిపుల్గా ఉంటాడని అంతవరకు నాకు తెలియదు. ఆల్రెడీ డాక్టర్లు పిచ్చిపుల్కాలని నాకు మంచి ఐడియానే ఉంది. నేను చాలాసార్లు చూపించుకున్నాను, ఎవడి వల్ల ఏం కాలేదు. నాకు రైస్ ఇవన్నీ తినేటప్పుడు దగ్గు ఎక్కువగా ఉండేది. అది రైస్ తినడం వల్ల, గోధుమలు తినడం వల్ల, గుడ్లు తినడం వల్ల వచ్చిన రోగం అది. అది ఏం చేసినా క్యూర్ అవ్వదు. 110 మంది డాక్టర్ల దగ్గర పోయినా చిన్నప్పటి నుంచి. ఎవడు ఇన్ని ట్యాబ్లెట్లు ఇస్తాడు, వాడడము మింగడం ఏమీ కాదు లాస్ట్కి. అర్థమవుతుంది కదా? సో డాక్టర్ల మీద నాకు నమ్మకం లేదు బేసికల్గా. తర్వాత మా అమ్మను ఆ హాస్పిటల్కి పిలుచుకోకపోతే ఈ కడపలో ఉండే హిమాలయాలోనే వాడు ట్రీట్మెంట్ చేసి టీబీ ఉంది నీకు అన్నాడు. ఏమో లేని మా అమ్మ 6 నెలలు వాడింది ట్యాబ్లెట్స్. మొత్తము ఫార్మాస్యూటికల్ మెడికల్ కంపెనీస్లో ట్యాబ్లెట్స్లో టీబీ మెడిసిన్ చాలా పవర్ఫుల్. అది వేసుకోకూడదు. అది రోగం ఉంటేనే వేసుకోవాలి, లేదంటే వేసుకోకూడదు. వేసుకుని మా అమ్మ తూగేది ఇట్లా. 6 నెలలు వేసుకున్న తర్వాత మళ్ళీ అది అట్లే ఉంది, ఏం తేడా లేదు. ఆ దగ్గులో కానీ ఆ ప్రాబ్లంలో ఏం మార్పు లేదు. మళ్ళీ ప్రేమానందన్ తిరుపతిలో ఒక డాక్టర్ ఉన్నాడు. ఆయన దగ్గరికి పోతే ఆయన హీఈస్ అ వండర్ఫుల్ డాక్టర్. అటువంటి వాళ్ళు డాక్టర్లు అంటే యాక్చువల్గా. అతని దగ్గర పోతే అతను స్టడీ చేస్తున్నాడు కేసుని మొత్తం. స్టడీ చేసి చూస్తే ఇది టీబీ అని నీకు చెప్పింది ఎవడు మా అన్నాడు ఒకటేసారి. ఇది టీబీ కాదు తల్లి, ఇది నువ్వు 6 నెలలు ట్యాబ్లెట్ వేసుకున్నావు, లివరు కిడ్నీ ఇవన్నీ లేచిపోయింటాయి, ఒకసారి టెస్ట్ చేద్దామని టెస్ట్ చేయించినారు. దేవుని దయ వల్ల ఏమీ కాలేదు. లేకపోతే ఆ పాటికి లివరు కిడ్నీ అన్నీ చెడిపోయి ఉండాలి ఆ మెడిసిన్ దెబ్బకి. అర్థమవుతుంది కదా. ఆ ప్రాబ్లం ఏదో రెక్టిఫై చేసి తర్వాత ఆయన మెడిసిన్ ఇచ్చినాడు, అప్పుడు ఆమె క్యూర్ అయింది. సో అటువంటి డాక్టర్లు కావాలంటే మీరు మన షారూఖ్ ఖాన్ ఒకే ఒక డెడ్ బాడీ పోసిన మెడికల్ కాలేజీలో చదివినారనుకోండి, ఫాతిమా లాంటి కాలేజీలలో ఇట్లాంటి డాక్టర్లు అవుతారు. తలనొప్పించి నుంచి నీకు బ్రెయిన్ క్యాన్సర్ ఉందని చెప్పేవాళ్ళు వీళ్ళంతా. అర్థమవుతుంది కదా. అట్లాంటి దరిద్రమైన డాక్టర్లు కాకుండా మీరు నిజంగా సొసైటీకి యూజ్ అవ్వాలంటే పెద్ద కాలేజీలలో పెద్ద డాక్టర్గా మారాలి. గాడ్ కెనాట్ సేవ్ ద సొసైటీ ఇఫ్ యూ పీపుల్ బికమ్ డాక్టర్ అన్నట్లు. ఓకేమా. సో ఇది సెకండ్ ఈక్వేషన్ కదమ్మా. K1 + U1 = K2 + U2. దీని నుంచి ఐ విల్ గెట్ సెకండ్ ఈక్వేషన్ ఫ్రమ్ దిస్ వన్. ఓకే. సో నౌ స్టార్ట్ సబ్స్టిట్యూటింగ్. ఇనీషియల్ కైనెటిక్ ఎనర్జీ 0 నమ్మా. When they are in infinite separation, there is no velocity. So initial kinetic energy is 0. Initial potential energy minus gmm by r. R is infinite, no? So again, initial potential energy also will become 0. Okay, because they are at a very large separation. Kinetic energy is also 0, potential energy is also 0 initially. Final kinetic energy, so both bodies will have kinetic energy, no? This body also has some velocity, this body also has some velocity. So half m1 v1 square plus half m2 v2 square. Both bodies have kinetic energy. Final potential energy minus g m1 m2 divided by what is the separation ma? R. Okay. Now here also I have 2 unknown quantities, no? But unknown quantity already we have calculated, no? So what I will do, okay ma? So first you take v2 value is how much? v2 value is m1 v1 divided by m2. Okay. Take this value and substitute in third equation. Let it be second one. Okay, ma? Substituting 2 in 3. Therefore, what I will get 0 is equals to half m1 v1 square plus half m2 v2. v2 value is how much, ma? m1 v1 by m2 whole square minus g m1 m2 divided by r. Now everything is present in terms of v1 only, no? So calculate v1. That is my answer. Once you get v1, take this v1 and substitute here, you will get v2 also. Once you get v1, v2, substitute in this equation, then you will get the relative speed of approach. Arthamavutunda process. Now from here I hope you can do, Nama. Do it. So first you calculate v1. Once you calculate v1, if you substitute in first equation, you will get v2. Once you get v1 and v2, substitute. This is my required answer, no? Relative velocity of approach, v1 plus v2. Do the calculation. Okay. Okay, so see. So therefore, this is the final answer which you should get, root 2g into m1 plus m2 divided by r. So v1, calculate v1, then by using this calculate v2 and substitute in this equation, then that is the answer which you should get. First method of solving. Okay, ma? Completed? Now let us go for one more method of solving the same problem. Ma? Okay. Okay, ma? Second method of solving is by using the concept of reduced mass. Okay, ma? Reduced mass. Okay. See, ma, when masses, when they are moving by mutual force of attraction without any external forces, then instead of 2 masses, you can take 1 mass. And that mass is called as reduced mass. So in simple harmonic motion also, I have given some problems on reduced mass. Do you remember? Say for example, so these are 2 masses, m1 and m2, okay, ma? Connected to this spring, and they are oscillating. Okay. Then instead of 2 masses, I can take this total to be 1 mass only, whose reduced mass is mu. What is meant by mu? Mu is called as reduced mass. Okay, ma? And what is mu value? It is m1 m2 divided by m1 plus m2. This is called as reduced mass. It means instead of two masses, I can take a single mass. Single mass means how it will convert? It will convert into a single spring connected to a single mass. And mass is reduced mass. And spring constant of this spring is k. This is also k. Then what is the time period of oscillation? T is equals to 2 pi root m by k. No, instead of m, I will write mu by k. These methods we have used in SHM. No? Same method I will try to use here also. The concept of reduced mass. Okay, ma? How I can use? Let us see. So again, use the law of conservation of mechanical energy only. So K1 plus U1 is equals to K2 plus U2. Initial kinetic energy, 0. Initial potential energy is also 0 because they are at infinite separation. Final kinetic energy I can write half mu v square. I can write like this. Final kinetic energy, instead of two masses, I am taking only one mass. No? One mass means only one velocity. So half mv square, no, kinetic energy. Instead of m, I am writing mu. What is meant by mu? Reduced mass concept. Clear, no? And what is the kinetic energy? Minus g m1 m2 divided by r. That is common. Are you able to understand? Ma? Now just calculate v value. That is my required answer. Okay, ma? So half mu value is how much? m1 m2 divided by m1 plus m2 multiplied by v square minus g m1 m2 divided by r is equal to 0. From this, what you are supposed to calculate, ma? You are supposed to calculate v value. That is my required answer. Have you understood? That's all. Okay. So whatever we answer we got in the previous condition, same answer you will get here also.